Hello and welcome to another video. In this video we're going to be working on word subsets. And in this one you're given two string arrays, words 1 and words 2. And the explanation is kind of bad, so I'll explain this simpler one. So basically a word is a subset of another word if every character of that word is in the other word, the amount of time it needs to be. So if, like this word for example, has one E, in order for this word to be a subset of another word, that word has to have at least one E. And then if you have multiple characters, then the word that you're trying to be a subset of has to have all those characters with that exact count or more. So the basic definition is like, for a character, or for a word, to be a subset of, I guess for X, let's do this, to be a subset of Y, the count of every character in X has to be less than or equal to the count of that same character in Y. So that's the basic definition there. And then there's also this universal thing, which just basically means that get words that every single character or every single word in the second words is a subset of. So in these examples, like we're given a subset array words 2, or just words 2, and we need to get words from words 1 where every single word in words 2 is a subset of words 1. So essentially, this has to be true for every word in word 2 array given a word in word 1 array for that word to be in the answer. So now let's look at the examples. So in this example, we're basically looking for every character that has at least one E and at least one O, and that's these ones. And second example, we need at least one L and at least one E, so that's these ones. And so these are simpler examples, but let's just think about, like, let's just take some bigger words. Like, let's actually take some of these. Like, let's say our two, like, we have an array of words that's like Apple and Facebook. So in order for Apple to be a subset of another word, that word has to have at least one A, at least one E, at least two P's, or let's move this down actually. There we go. Okay, so one A, one E, and then, yeah, one L, two P's. And then also, in order for Facebook to be part of that word, it has to have one A, one B, maybe I'll miss something, let's see, one C, one E, so, and then one F, and then one K and two O's, I think, right? So that should be 8, or, whoops, okay, yeah. So, if we want a word that both of these are a subset of, like, and we can have multiple of these, then basically the word has to have, for each of these, it has to have that character frequency. So if we have a bunch of these words, right, let's just make a couple more words, just like fake words. Like, let's say we have another word that's like these exact same characters, but it has like 5 E's. And then let's have another word that has these exact characters, but it has like 5 K's. So what does a word have to make sure that all of these are a subset? Well, for every single one of the characters in each of these words, we can just take, like, which one occurs the most. And if that character, and if we make sure that, like, the word we're looking for has that maximum, then it's going to satisfy everything else, right? So in this case, like, let's say in this one, A was like 5 times. So if we can satisfy this constraint in our word, then we're going to satisfy all these smaller ones. So essentially what we can do is we can just take every word, break it down into word counts, and just take the maxes for each count. So it's actually not going to be word counts, it's going to be character counts. And that's all we need to do, because if we can satisfy the max character, like if we can satisfy the word that needs the most A's, then we can satisfy everything else. Then we take the one that needs the most B's, most C's, most D's, and so on. And you can do this. So for every single word, you can either make a dictionary or an array of 26 characters, or you can just kind of compute this in like a running problem, and then you only need to store 2 at a time. So basically what would happen is you're going to start with an initial empty dictionary, And then for the first word, you're going to get this. So this will basically be your starting like counts. Then once we get to the second word, we can just say like, okay, this is the count for the second word. Let's compare it to the first, and let's just store the maxes in our running total. So what that would turn into is basically this, but we have two P's in here as well. And then we also have an L, looks like. And I think that's it. So our new running total is just going to be this guy. So that's our first two. Then when we bring in the third word, we're going to take the maxes again. So we have 5 A's, we have 1 here, so this will turn into a 5. B will stay, C will stay, E will turn into a 5. F will stay, L will stay. This is done. And then the last word. And the last word is not going to change anything except for this K. So if we have this, then we will satisfy every single word. We basically just took the maxes of every single character. So if we go back to our original, I think it was like this. Yeah. So if we actually just paste this, like as long as our word in words 1 has at least this for every character, it's going to satisfy all of these. And that's basically all we need to do. So we're just going to go through words 2, get a word count for each word, maintain a running total for each character, or get a character count for every character, maintain a running total. And then for every single word in words 1, we're just going to get the character count and make sure that every single character count in words 1 is at least these numbers. And if it is, then we'll add it to the result. All right, so let's code that. So first thing we're going to do is we're going to keep track of a character count. So we can just say like counts, and it's going to be 26 length. Actually, yeah, this is right. And then we can just normalize every character like I've been doing a bunch of other problems. So A will be 0, B will be 1, and whatever. So we're going to go through every single word. So let's just go through, so 4. We don't care about the index, word, in words 2. So we're going to get like this current count or something. And then we're going to make this new array. And then we're going to go through every single character in there. So we can just say like word. So we're going to increment the count in current count. And that's going to be the word I is going to be the character. And then we need to normalize it by subtracting A. Okay. And now that we do that, then we're going to basically compare our counts array to our current counts array. So we're essentially going to loop again. And then this is just going to be counts of I equals the maximum of the old counts of I and the one that we have for this word. Okay, and that should be it. So now we're going to have this counts array of like the count we need for everything. So now we can make our result. That's just going to be a string slice. And we can go through every single word in words 1 now and do the same kind of thing. So let's just go through words 1. We're going to get this current count, same thing. This is all the same. Except now what we need to do is, so what we can do is we can either, there's a few ways we can do it. I think what we can do here is we can just preemptively add the word to the result. And then if this fails, then we can just pop it and be done. So that's one way to do it. A bunch of ways, doesn't really matter how. So we're just going to add the word preemptively. And then if the counts, so counts is how many we need. So if the counts of I is greater than current count, actually, no, this is going to be wrong. Let's see. No, actually, no, this is right. Yeah, so current count is how many we have in the word. Yeah, that's fine. So if the how many we need is going to be greater than a current count of I, then essentially this word is no good and we can just pop it and be done. So, and just break out of here and we're done. Alternatively, you can have like a Boolean variable that you just set as like true, and then if this ever fails, you just set it to false. And then if it's true at the end, you just append. Either one, it doesn't really matter. And we can return the result and see what errors we have. This needs to be a range. Range. Okay. Let's see. All right. Anything else? Okay. So yeah, that's basically the trick to this problem, is just realizing that I can't, for every single word in words 2, check for the count in words 1. That would be unsquared. Instead, I'm just going to build up one big constraint that I need by going through these, and then check for that in the other one. And because basically this one big constraint is only 26 letters, like essentially here we're only storing 2 arrays at most. And then here we're also only storing 2 arrays at most, right? Our original array and the one we have for every word. So we basically have a one-space solution. Curious what it says here. Yeah, so a one-space solution. And this should just be going through the words. Yeah, essentially. Okay. So yeah, basically the time is like m plus n, where you go through every single word. You can break it down to characters if you want to. And space is of 1, because essentially we just have like 2 or 3 arrays that are constant size. So yeah, so hopefully this is helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.